Now let's have a look at where images fit into all this. So with virtual machines, you can create a snapshot of a VM and have it as a backup and restore it. And that image is something that's static on disk. It's similar with Docker images, except here images are a bit more fundamental and used as part of your everyday workflow when using Docker. Basically, a container is an instance of an image. In this diagram, we can see that 3 containers have been spun up from the same image. And whilst they're different containers, they will be identical because they're created from the same image. Anything that happens in one of these containers after it gets created will diverge from the others. So if my application writes to the local file system in the container that it's running, that change won't happen in the other containers. The image is just like a template from when that container is first created. Now, if I have an application that I package up using Docker and I want a colleague to run it, I wouldn't be sending that colleague a container, as that doesn't make sense, given that a container is an instance. What I do is create an image and upload that image somewhere for my colleague to download. Then they can create their own containers from that image. So moving over to a different diagram here, just to explain this. So imagine I'm Bob. I've built an image of my web app. I push that image to a container registry, which we're going to talk about in the next section. The default one is Docker Hub, which we'll talk about, but it's not the only container registry. Then some point in the future, Jane pulls down that image and creates a container from it. The Docker tooling does this for you, but basically the tooling is pulling this image down and creating a container from it. So in this last part of this section, we're going to talk about container registries. I covered them a little bit in the last section, and I mentioned Docker Hub, which is the default container registry, but it's not the only one. So for example, Azure has Azure Container Registry. AWS has Amazon Elastic Container Registry. Google has the Artifact Registry. GitHub has one. There's also open source options like Hub is quite a popular one. Docker Hub, though, does much more than just store your own images. It's actually, well, it's the default one, but it's also where there's millions of public images which you can download yourself, so third-party images. So if we go to Explore, now this number here, 10,000, I'm sure this used to show the full amount, but it's now capped, and I'm pretty sure it was in the millions. I can't find a way to actually find out how many there are at the moment. Maybe they've changed it. So we can see we've got images like Nginx, Redis, Postgres, Node, Mongo, MySQL, lots of them, RabbitMQ, Hello World, which is the one when we installed Docker, the one we saw, which we tested to make sure it was working, WordPress, PHP, InfluxDB, you get the idea, so there's lots of third-party images. If we jump over to the pricing section, then we can see that the personal free one has unlimited public repositories. So it's important to note that if you upload your images as a public repository, then anyone can download your images. So if it's your own application, which isn't an open source public thing, you probably want to use the paid for version or one of the other options to host your own private images. In the same way as with Git, they use the terminology push and pull. This uses the same terminology. Rather than saying upload an image and download an image, we use the term push an image or pull an image. And if we actually go to any of these, let's just pick one. Let's do Redis. You can see the command here, docker pull Redis. So if we run this on the command line, and in the next section we'll be looking at the Docker CLI, then this is going to pull down the image to your computer. It won't do anything with it, but again, we'll talk about that in the next section. And with that, I think we've done enough theory. I think now is a good time to actually jump in and try this stuff, just so the concepts we've covered so far can start to click. So first up, we're going to look at the Docker CLI. So that's interacting with Docker on the command line. Now, don't worry if you're not a heavy CLI user. There's pretty much one command we need to deal with, and that is Docker. So if we run this, then we get a whole bunch of help output. And scrolling up to the top, conveniently enough, they've listed the common commands at the top, which is quite nice. Scrolling down this list, Note we've got Docker Swarm here, Swarm commands. So Swarm is Docker's container orchestration platform. Now, to be honest, Kubernetes has won this war, so we're not going to deal with, in this course, Docker Swarm. Scrolling further down, we've got some more commands. Right down at the bottom, we've got Docker, it says run Docker command, so whatever command we're looking at, --help. So that's a great way of digging into the commands and finding out how that command works. At the bottom as well, there's docs.docker.com, which is a fantastic reference for all of these commands and lots of Docker stuff. So that's something you'll definitely be looking at as you're playing around with these commands. So if we type docker run nginx now, I picked an arbitrary image nginx, and you can see this is now downloading the image. So the docker run has implicitly done a docker pull because it saw that the image didn't exist locally. And then you can see that it's run the container from that image, and it ran it really quickly, even though it took 30 seconds to download the image. It's worth pointing out that the image is cached, so it's not going to do that every time. Now, if we open up another tab and we type docker ps, so docker ps lists the containers. So this is listed out nginx, and we can see that it's been created 39 seconds ago. It mentions a port, so we can access it on port 80, which is what we saw it doing when we went to localhost. It's given it a random name because we didn't specify one, and it's got a container ID. If I type docker stop now and give it that container ID, then we can stop the container. It doesn't delete it, it just stops it. So now typing docker ps again, then we can't see that. But if we type docker ps -a, we can see it because A shows all containers, including stopped ones. We can also remove that container. We can do docker rm and then that container ID, and that'll remove it completely. So now what we're going to do, we're going to run that command again. And when I hit enter now, I want you to note how fast it spins up because the image is already cached. So I've already downloaded that image, so it's just going to create a brand new container from that image. You ready? That took a fraction of a second. That was just immediate. So you can now see the difference when I was comparing VMs and containers. These are so lightweight, so fast to start up and spin up. So next up, we're going to look at what we've just seen now, but using the Docker Desktop GUI. If you install Docker via installing Docker Desktop, then you will have the Docker Desktop GUI. So on the left-hand side, we can see we've got containers, images, volumes. We'll talk about volumes later. This view, containers, we can see looks very similar to the docker ps command on the command line. It's showing the name, it's showing the container ID, the image that container was based off, the status, how old it is, and various other things. One difference is that the container name and the image name have hyperlinks, which means that we can drill down on them to get more information. So for example, if we click on the container, we can drill down and we can see logs. We can inspect the container and see information about that container. We can get a terminal, so we can type commands within that container. We've got a shell. We can look at files within that container. Stats, so like things like CPU usage, memory usage, and disk access, network access for this container, which is quite powerful. If we go back to this view now, then we can also, as well as drilling down on the container, we can drill down on the image. Now doing this is just a shortcut through going to the images view, which this lists out all of your images you've got on your machine. Now, for me, normally this would be a huge list because I use Docker quite heavily. I cleared them out before doing this demo, but normally this would be quite big. It's all your images. So I could click on Nginx here, or it's the same as actually clicking on it here. So going to this actually shows quite a lot of useful information about this image. So things like the image hierarchy and layers, and we'll definitely cover that in more detail later. So from this view, we can also see the status. We can stop the container. We've got various options. So things like copy docker run command. If you wanted to copy that into a script, for example, that's quite useful. We can pause, restart the container. We can delete the container. So a lot of the things we would do from the command line, we can just do at the click of a button here, which is quite nice. We can also show charts, so we can show across all of the containers, CPU usage, memory usage, which is quite nice. And it's worth knowing about this learning center. even though this course is going to cover a lot of Docker stuff, this is a very good quick reference to quickly jump to the documentation for reference, which is really nice. So another thing that's quite useful is this search bar at the top, so we can search for local and remote images, containers, and various other stuff. So if, for example, I type RabbitMQ, so that's just another third-party image, then it finds it in Docker Hub, I can click on run, and it'll quickly download and spin up a container from that image. And straight away we've got RabbitMQ running, and that is so powerful. How fast did that take? So this really starts to highlight the power of Docker, the fact that something you've not even had installed or used before, you can just very quickly spin up. Another thing I want to show in Docker Desktop is this bug icon. Clicking on this gives you this menu option. Now, sometimes Docker doesn't play nicely and it gets in a bit of a funny state. You can just restart it here or reset to factory defaults. Sometimes this is just a nice start again option. Also, images, if you've been using it a while, that takes up a lot of disk space. So images are quite big, containers are quite fast and lightweight. So if you've been using it a while, you might have lots of images. So sometimes it's nice to just click and purge your data and just free up some disk space. To the right of that bug item, you've got a cog option with the settings. This has a whole bunch of settings, which is worth looking through. It's also worth pointing out that Docker Desktop comes with a local version of Kubernetes. So obviously Kubernetes is out of scope of this course, but it's worth noting that Docker Desktop does come with it. So at the click of a button, you can have a single node cluster running with Kubernetes, which is quite nice. So the next and last part of this section is going to quickly show interacting with Docker via the VS Code extension. And lastly, let's have a quick look at the VS Code Docker extension. So it's worth pointing out that pretty much all modern editors and IDEs have some form of Docker extension or integration. I can't show them all, so I'm just showing VS Code. Things like the JetBrains IntelliJ, so all of their IDEs, Visual Studio, they all have Docker integration, but I'm just going to quickly show VS Code. So if you go to extensions and search for Docker, I've already got it installed, but you can just install it quite easily here. And then you'll have on the left-hand side this Docker icon, which will take you to this, which should hopefully by now start looking quite familiar. We've got a list of containers, and this is allowing us to drill down and look at the files within it. We can view the logs quite easily. We can attach a shell and have a terminal, so like we did before doing ls, for example, or whatever command you want to run in there. We can inspect it so we can get some JSON showing just a dump of information about that container. And also we can see images. Now it's worth pointing out that we can see here I've expanded Nginx and it's showing a tag. So latest is a tag, and I'm going to talk more about tags later, but an image can have multiple tags and they're like versions. So the same image name, but different versions. But we will dig more into that a bit later. So that should give you a really good idea of how to interact with Docker in different ways. So in the next section, we're really going to get our hands dirty and start playing around with Docker.